have seen before when you work with Grasshopper is all these different sub-menus until here. Now, when you go to the data bar, there should be added this extra one called Geometry BIM. Within this, you will find the first one called Rule Element, and in here there's a number of elements. This is general elements that will help you do a truss or other geometry thing, but it's not directed as a specific find element program. So these elements in here you can use whichever program you're going to export it to afterwards. Then here I have some extra. This is for GSA, and then I also have two for robot. One to create the structure, elements to create the structure, and one to do loads and to export to robot. So these two will be the same for robot as they are for GSA, which is a alternative find element program. Okay, so I'll try to run through a simple BIM with you. I'll start up making 2 points. This one to go into vector and go in and grab a point here. You also have to keep in mind when you work with this that if you work in millimeters in robot, then you should also do the structure in millimeters here. Otherwise, you will get some issues when you export it because it will be out of scale. You might also have the problem when you import it into robot that the numbers are completely off, and then it can be because robot is set up for American dimensions. All right, that's so here I create my first point, and then I copy it and change this one to 10,000 and put that into the X input. So here we have 2 points, and we can go into curve and pick a line and add a line between, which could be the baseline of our beam. Then we go into Geometry BIM, and we go to robot, and we find the robot create beam. We use this element. For this element, you can either, as you probably have noticed already, when you have your mouse above one of the inputs, then it writes to you what it wants for the input. For this one, you can either put in curve or a number of curves, or you can put in 2 points. So either we can just put this one into the first one, or we can put in the first point and the second point, and it will be the same. It just depends on the other data we have, whether we have a number of lines or we have a number of, if we have 2 series of points that we want to combine into beams. I just deleted that one now. Okay, so we still haven't got any beam yet. What we need to go to here is that as when you create a beam in robot, then you need to know, of course, between which points, but you also need to know what are the section properties, and what are the material robot again and find there's one called section properties. Just this one, robot create section properties, and we put that into here. This one will ask for both a profile, a name, and a material. When we want to make a profile, then we go into this boolean, which was the common one for whichever of the find elements the programs we are working with. Here we have two options, or we have a number of options. One of them is to choose this one called the catalog profile. Within this one, when we double click on it, when we right click on it, sorry, you can choose which kind of profile you want. All of them are, yes, all standard profiles should be in here. So this is the easy way. If you're working with a standard profile, you can also go down here to the bottom, and then you can choose one of these types of elements. And here, for a H or I profile, then you put in the specific dimensions you're working with on a specific profile. So this is, yeah, two of the same options. We just go for the standard one now and put it into here. Then we need the material, and here you can choose between typical materials and all other kinds of materials. And we want to make a steel structure, so choose one of the others. So I have to move this a bit. What you should know with this material is that it is for standard set up to be a normal steel material. It wants a name, and then you can see here all the parameters that you know from when you do a calculation, and you can put that in and you can change it. So if you add something, then it's changed, and if you don't add anything, then it's a steel material. We need to call it something. So now it's turned into gray because all of the other materials is already in the components. And then we add that one to material here. It's still yellow because, as you probably know, when you have your mouse about this little ball, then it will tell you what it still needs to get data into. And we need to call this something. And of course, if you work with a lot of different profiles and so on, then you can organize it in different ways, whatever you want to. Okay. So now that one turned into gray, and when you see over here, then we have the section that we put in here. So all these elements we have up here is material and the section properties. What I can do now is I can say, okay, this is all I want. I go into robot. I go and pick the special bake button for the robot. Sometimes you just want to have your geometry put into robot in the right way. And then this would be enough. You double tap the bake button, and then it starts bake a new structure for robot. There you go. We are in the robot environment, and we have our beam. If we add the icon for the profile, then you can see that it's the profile you chosen in the Grasshopper environment. I don't know if you are familiar with robot. We won't spend this lecture going into detail of robot. I just want you to be able to run a simple calculation so you can see if your data is transferred in the right way. Normally up here it will say which lowercase there's on, but since we haven't put any lowercase on, then there's nothing up there yet. Down here there's an icon where you can put on the support, and it will show here, but we still haven't put any support on, so it just simply shows the beam. This would still be an advantage if you have a complex geometry that you can put it in, and then you can add the loads to support in robot as you would do if you build up the model in robot. Alright. There you go. But we want to put some supports in the ends of the beam. So we go back. We choose this robot create or find node. What you should be aware of is that this can be used for support, but it can also be used if you want to add a node. You cannot add a node if you don't have a node to add it on. And that's because that's the way it works in robots. So of course, you need to set up the geometry on the same way in Grasshopper, because otherwise the robot won't understand. It asks for which points, and then we take the endpoints from our beam. Now it's gray, so you can do two things here. This is the first one is node release. That is to know whether it's fixed in one direction or another and against bending. So either you can right click, you can go down here, and then node release, and then you can take out the in which directions you want it to be fixed. You can also go up here, and that might be a bit more simple to begin with, because then you can actually easily see what you have set it for. And choose this one called robot node strength. That one we add into here, and then we go to params and choose our true and false button. A standard they are set to false, so if we want the first one to be fixed in all three directions, then we add that for it. I will copy this one, so I have for my next point. This one I don't want to have fixed in the in the X direction. What you should be aware of is that supports and loads is not shown in the Rhino environment, so you can only see it when you transfer it into robot. So now we have these elements that has created our supports, and if I bake the structure again, I've totally lost you, then you should let me know, and I'll try to explain some of it again. Now when I go to robot, then you can see that the preferences I set up for the nodes, I imported into here, and that was because this icon down here will show how the supports are, and you can see that we have the profile as well. But we're still not finished. We want to add loads to our beam. do that, we go up to not the robot, but the robot solver menu. In here we can create both a load combination and we can create just a single load. I'll just go for a load. And we want to have the load, in this case, put on a curve because it's a beam, so it's a straight line. Well, it can also be not straight, but so to add this, it asks for the load case that we brought down before. The load case wants to have a name, so we can identify it when we have it in robot. As if we do a load case in there, you would do the give it a name straight away as well.
You put in the load case and what was the other parts?
Sorry?
You put in the load
This one is the load case, and this one is the one that adds the load onto the elements.
okay.
The next thing it's asking for is the ID number. If you have multiple loads, then it's important that you give it a different number because in robot it will have different numbers. So if it's all for one, then it doesn't work because the robot is confused that it has 10 loads with the same ID. Yeah. Then we add the, here it wants to have the elements. Sometimes, and I don't remember if this is the case with this one, then you need to group the elements before you put it into a load. And that you do with this one, which you find on the robot. Down here, and sometimes you don't, so we try to start out with that. Then of course we need to add a force as well, so we know what's going on. And the force you add by going into vectors and then pick a vector. In this case we want it to be in the Z direction. And then we want to put in the size. So now we have added a load and we can control the size of it here. We can also add it with a different direction depending on what you're looking for. So these elements now create, this is the load case. This is the size of the load, and this one is the one that combines these two and put it on the elements that we have put into it. So let's try to make it again. So now you can see up here you can actually choose a load case, and we call it load case 1, and it has the number 1. So that one, and we can go down here and add, so we can actually see this one shows the load, and that one shows the size of the load, and we still have our supports. So now we have created a simple beam. We can go up and press the calculate, and then I forgot some of the supports. Yeah.
The load curve, the calculate somewhere with which force was it?
The
Say, you have asking grasshopper.
just to go back to your question, this was the this one simplifies the beam that we have created, and the beam I put into the element that combines the loads to yeah. I mean, if I had a surface or if I had a number of beams, then I would put that into E instead of just this single one. Okay. This is a way to build up a simple beam with a uniform distributed load. As I mentioned before, you can also create a joke in one node instead of doing it on an element. I just realized that this one isn't uploaded for you yet, but as you have seen some part of it last time, I will upload something right after here that will explain all these different functions one by one and how to combine them. I just want to run through one more thing. Just copy. Okay, I have reused my 2 points from before, and now I want to do the geometry of a truss, because there's some functions within geometry that helps you create that in a simple way. We start out with combining these 2 elements, so we have a curve. And this would be the lower part of our truss. Then I will use transform and go and find the move tool, which is similar to copy when you work within Grasshopper. And then I will add a vector in the Z direction, and I want to have a upper curve that is 2 meters above. Okay. Now we have 2 lines, an upper one and a lower one. And then when we go into the tool and menu, then you can find down here truss from curves. That element we add. We have the 2 curves we need to add. I have the lower one and the upper one. Then it wants to know how many divisions we have in our truss. So I add a number slider. And then it had created a truss for me. But of course there is different types of trusses, as you know. And in here we can choose this one for truss type. Here we can also right click on the double T truss type, and then you can choose which kind of truss you want in here. But you can also add this extra element. This one so you add a number slider again, and then each type have different numbers. So here you can see that I can choose between different types of trusses. All that is in this, you can also do that just by purely Grasshopper scripting. But this component just assembly a lot of the functions into one, so it's more simple to work with. Okay. Yeah, I won't go through it here, but in the notes you will have, there will also be a page showing how you do a surface and transfer that. If you work with surfaces, then you should be aware that if you have a double curved surface, you should change it into a mesh, and then each of these small elements in the mesh are a panel. And if you have a straight surface or a blank slab or whatever you want to call it, then it's just one element. All right. I'll see what was. Oh yeah. Then I want to show you a task or exercise that we had last year. I will start saying that last year they had 2 more lectures within this, but this is a truss made within this script, and of course when you look at a flat truss, then it's probably tricky to do it in robot. If you work with a truss following a double curved roof structure, then it will take you quite a long time to build it up. And when the architect or the service guy come and say that you need an extra ventilation, so you need to change one of the points, then it will take you another month to rebuild your robot model. This one, if I choose surface and the control point for it, into this view, I can move this point up, and then you'll notice that the truss is just following the surface and rebuilding. This truss, you can, its support in 4 corners, there are added loads to all the joints up here in the roof surface, and I can try to export it into robot so you can see if it works. Of course, this one is a bit more complicated, so it might take a couple of minutes. But yeah, still compared to do it manually, then it's quite quick. You can always follow up here how many of the elements that it has transferred, and whether it's baking or whether it has a fault. Most of you seem still awake. Glad to see. Any questions while we're waiting? Oh, here it is. Oh yeah, what you should also be aware of is that sometimes when you go into robot, then you cannot see it, but when you start rotating, then you get in your entire surface. So here we have the structure in here. We can see here that I've added loads to all the points, and I can try to run an analysis on it. Oh. It worked an hour ago. I don't know why it crashed. Yeah. Anyway, okay. So what's on the program for you today? I just want to finish off saying that within this geometry BIM, there's plenty of alternatives to it. With this one, you can also, as I mentioned in the beginning, you can export to different platforms. There's also, if you do for structures, there's also a plugin called Rhino-Grasshopper, which do define element analysis within the Grasshopper environment, so it's not sending anything to another program. It's always a discussion of what's best. It might be a bit more intuitive to work with all of it within the same environment, but exporting it to, for example, robots has the advantage that robot and other fine element programs are well known, so you don't have to verify the results in the same way as if you do it all within Grasshopper. I haven't mentioned it yet, but it's also mentioned in the course material that on the web page for this, there's also links to a lot of YouTube videos showing how to link to these different programs and to build up some of the models. There's two exercises today. One of them is to make a truss at point loads to some of the joints up here, and then